Thanks to Chinmay for a lovely introduction. The energy in the room already seems to have dropped, and I'm sure all of you are more than hungry. But I hope you can bear with us for this session while we take you through a little bit of research in the area of technology as well as digitalization and AI from India to the world. And with me is Dr. Venkat. And I'd like to start by asking him what he's been doing at Microsoft in the area of AI applications.
Yeah, thank you, Swathi. It's wonderful to be here with you. I also want to thank Ms. Rama. I think I met her last month at an event, and that's when she told me about this, and I think we met Vaidi as well. So it's wonderful to be here. Before I answer your question directly, let me sort of provide my way of looking at research and its role in society, right? We all like to advance scientific knowledge, understanding, and that's really part of research. But I think the biggest satisfaction many of us get is when work we do makes a difference to people who we have never even met, who are perhaps on the other side of the country or other side of the globe doing things. So when I look at the work that we do at Microsoft Research here in India, a lot of our work is of a kind where I would say broadly two categories, what I would call a sort of geo-independent research, work that could be happening anywhere, and I'll maybe get to that later. But a lot of it is motivated by problems we see in the real world that are really ripe for being solved with technology, whether it's AI or other things. So just to give you some examples, I would say early in the lab's history, we just turned 20 years in India, but early in the lab's history, there was a project called Digital Green that looked at the problem of or the lack of information in the hands of farmers. Just in terms of best practices, when to sow, what to do, and so on. And so it started with a very simple idea. Can we just create a farmer-to-farmer, sort of almost a peer-to-peer network for farmers to record videos for an audience which is other farmers? And that started, 18 years ago or so. We spun it out of the lab. Today, it is perhaps the largest information provider in the agri space that is now using AI to index this large corpus of videos that have been created over 20 years or 18 years to then answer questions. There is an app called Farmer Chat that does this, for example. Similar things in healthcare, education, and other verticals as well. I just want to pick one other example because there's a little connection with ELCIA, because I think in 2015, we were thinking about road safety and what we can do about road safety, leveraging smartphones, AI, and so on. And I think I got connected with Ms. Rama, and she was, I think, CEO of ELCIA then. We thought, okay, maybe we'll do something in Electronic City because it seemed more manageable than Bangalore. In the end, what we ended up doing is a system called HAMS, H-A-M-S, which is now being used to automate the driver license test in about 40 RTOs across the country. About 2.5 lakh or more than 2.5 lakh tests have happened with our system, right? So the idea is, the reality is in India, about 60% of people apparently get a license without having taken a test, and the results are for us to see on the road, right? So the idea is you get into a vehicle with a smartphone, drive around, there's no inspector in the vehicle. The AI running on the smartphone gives you the test, essentially assesses your driving, and then at the end, you get a result. Right? What was nice about this system is, one is that, as we found out from user feedback, people trust technology more than they trust other people. So even if they fail the test, they don't feel as bad as they would have felt if a human had failed them. But the other thing that was unexpected is that we launched this just before the pandemic. And then soon after the pandemic, when testing and so on resumed, no human driver and inspector wanted to sit together in the same vehicle. So it was really good to have a system like ours where you don't need to have another human in the vehicle, right? So just an example, and I'll maybe get to this later. The success of HAMS really is with partners, and I will talk about that maybe when we get to that segment of our discussion. So maybe I can turn on and maybe ask you the same question, but in a slightly different way, which is, a lot of what I talked about was sort of user-facing, looking at end users of applications and so on. But, as at an industrial powerhouse like Siemens, you look at the industrial aspect of AI and technology. And I know we had some discussions about robots and so on earlier today, but I'd love to get your perspective on what you've been doing and how you see the opportunity there.
Sure. First of all, it's nice that you mentioned your lab turned 20 this year and ours did too.
Okay, good.
So, thank you. Thanks for the question. And like you rightly pointed, Siemens is in this space of industrial digitalization and industrial AI, right? In one of the previous panels, you heard Mr. Shrikanta Aradhya from Entity Data talk about two of the very prominent problems in manufacturing. And this is still largely prevalent today, and both of those are what I would briefly like to touch upon, but also keeping in mind the orientation of today's event, right? We have humans, machines, and meaning. So let me start with machines. So let's take the instance of factories, yeah? And factories are made up of what? Of a lot of machines. Equipment, assets like pumps, motors, chillers, compressors, and so on. And what would these factory owners like more than anything else? One, to get the best performance out of these machines for the best possible time, right? For as long as possible. In other words, you want to reduce operating costs and you want to ensure optimal life of these assets. But unfortunately, that's not always feasible because machines can run into issues, right? And what was pointed out is, can you predict when a machine can fail, right? And this is what we do with specifically predictive analytics. So we try to tell you what the remaining useful lifetime of machines are. We try to monitor the health of these assets, give you diagnostic information, also provide guidance on maintenance strategy of these machines, right? So all in all, by doing all of this, you are able to reduce carbon footprint along with getting all of these KPIs achieved. Now, one thing which Dr. Venkat mentioned was geo-independent research, right? Problem solving of use cases that are relevant across the globe. Now, where does India play a role in this use case, right? So, when we were developing this solution here in India, and this was deployed not just here but also outside, one of the very specific requirements that came from here was, all is fine, but we don't have also the somebody in the morning also spoke about the long time it takes for decision making and the need to be economical in our solutions, which could be seen as a restriction, but on the other hand could also be seen as an opportunity for innovating, for creativity, right? So in this case, while in the background it was using state-of-the-art machine learning and time series forecasting and optimization, what was really interesting about the solution is that we deployed all of this in-house using very low resource infrastructure. And that, I think, was really novel, that we then started adopting this also in other countries globally, right? Although this was not a requirement in the first place. The other thing that is interesting about this use case is that we have a diverse range of domains, right? So predictive analytics solutions exist in the market for a long duration of time. There's nothing unique about this, but building custom solutions is not cost effective. So the solution that we have at Siemens now that was built here is one that can adapt very flexibly to multiple domains. So it can work reliably on, let's say, coffee roasters in the food and beverage industry, on pumps, heat exchangers from the process domain, as well as chillers from the smart buildings. So that's one use case. And the other use case I'd briefly want to touch upon is related to humans, right? So now I said factories. Machines are one part of the story, but the picture remains largely incomplete without humans, right? And what we want more than anything is to ensure the well-being of our factory workers. Again, here in India, in one of our Siemens factories about 2 years ago, we had an incident due to which one of our factory workers unfortunately lost his life. And this could have easily been prevented. And the main root cause of this issue was that there was no compliance to standard operating procedures and to safety regulations. Now, it's not that people don't know about these regulations, right? There are training programs, there are educational videos that are shown, played to these workers who largely converse in local dialects time and again, but still the compliance is sometimes not so possible to realize. So again here, a solution that was developed was based on computer vision, a surveillance system for safety of workers, which basically tracks in real time the movements of factory workers and sends alerts, sends recommendations to people on their mobile phones whenever they are not in compliance, right? So things like, if a person is too close to a machine that is in operation but is not wearing some protective gear like a hard hat, that's a violation. It could be that a person is too close to a moving vehicle. Things like this now can be detected, and again here we're getting closer and closer to avoiding these kind of life incidents when it comes to hazardous situations. So I hope I was at least able to give you a glimpse of a bit of the industrial applications that we work on. And now I'd like to ask you again, Venkat, because you talked about a lot of end user facing applications and also the role that ecosystems play, right? You talked about your collaboration with ELCIA. You talked about how HAMS would maybe not have been as successful if not for the partnering collaboration. So could you elaborate a little bit more on that?
I think that's a really important question, so thank you for asking. Throughout our 20 years, we have been very much part of the ecosystem, right? Although Microsoft is a global company, the lab here operates kind of autonomously. We decide what we work on along with our local partners. I know we hosted Vaidi and his team just last week, and he has talked to some of my colleagues in years past as well. So for us, the ecosystem is academia, government, startups, NGOs, and anyone sort of who we think has either interesting problems or has complementary skills or has ability to take what's developed in the lab and sort of scale it and so on, right? So I'll just give you some examples. So we start with HAMS. We start with many possible use cases. We talked to ELCIA, we talked to others. Finally, we got somehow connected to Maruti Suzuki's CSR arm. It's called IDTR. And they were a wonderful partner. And then they in turn connected us with a really small but really nice company called Softex in Hyderabad. That is in the business of building IT solutions for RTOs and things like that. And all the scaling of HAMS that's happened over the past several years is thanks to Softex, right? We basically developed the technology, showed it worked, enabled them with our technology, and we just gave it away. We're not even charging for it. We just gave it, and then they've taken it, integrated into their solution, and now they bid for tenders, different states, and scale it, right? So that's an example of scaling. The other kind of thing we have done is worked with NGOs and in some cases turned our projects into an NGO. Like what I mean by that is we spun off our projects as a non-profit. For example, in the healthcare space, we were working on tuberculosis medication adherence, a project called 99 Dots. That got spun out as a company called Everwell, a not-for-profit company. It got funding from Gates Foundation and other foundations. And they've developed a platform called Nikshay, which you may have heard of. It's a health tracking platform specifically for TB that the government is now blessed. So it is the platform that the government is going to use for TB, actually is already using, not just in India, but I think in a dozen other countries. A third example is a project called Karya that we started in the lab. Really think of it as a project that was inspired by the MNREGA employment scheme the government has, but a digital form of it. How can we enable someone who's got a smartphone, got a bit of free time to do something useful, right? So a security guard sitting somewhere, they've got 15 minutes of free time, can they do some useful digital work? That was the origin of Karya. That also we spun out, and as the AI boom happened, the value of data and labeled data and so on became really apparent. And so Karya's business today is really about creating labeled data sets for Indian languages, Indian speech, and other such things. And they've also gone global. They were in fact featured on the cover of the Time magazine a couple of years ago. So these are all examples of sort of working with the ecosystem, NGOs, spinning off things from our lab, as well as working with SMEs like Softex and larger companies like Bharati. And maybe I should just mention one final example because that's also local. Just a couple of months ago, we announced an initiative with IIIT here in Electronic City, IIIT Bangalore, where we are working with the university and a few NGOs to stand up an initiative called A4I, which is AI Innovation and Inclusion Initiative, where the idea is to take some of the outcomes of our research and sustain it over time and grow it over time. So one of the problems as a research lab is that people in research move on to the next problem after some time, right? It is not a product, so then it might just die. So how do we sustain it? How do we turn this into a digital public good that lives on forever? And so that's really an initiative we started with IIIT. So I hope you got a sense of sort of the broad cross-section of interaction we've had with the ecosystem.
Yeah, I think you covered startups a little bit, established companies, universities, NGOs, all of it. So very nice.
How do you scale your solutions, beyond Siemens?
Scale is one aspect, an important one, and I think Siemens is a largely global organization, and partnerships with companies, including Microsoft, are well known, right? So even now in the area of generative AI, for example, Siemens partners with Microsoft, with OpenAI, with AWS for infrastructure, for models, and so on. So I think scale is kind of taken care, and in today's era, I think with the pace at which technology and digital landscape is evolving, it's also not possible anymore to build alone, right? We simply cannot do everything by ourselves. Somebody talked about islands of excellence, right? That's not going to work. And therefore, there's a lot of importance being given also to collaboration and to the partnering ecosystem. But let me come back to India, right, to where we are now. And you closed with IIIT-B, so let me start there. We have long-standing collaboration with IIIT-B, including PhD sponsorships, but also project engagements where largely the focus has been in AI and now generative AI for software engineering and systems engineering. So we have several projects going on in that direction. Now, in fact, we are in conversation with one of the professors there to start something off in the area of continual learning in never-ending learning in the space of AI. And CMTI is another close partner of ours. So Dr. Naga Hanumaya earlier mentioned about the smart factory that they have, not in miniature form, not in model form, but in function. And Siemens, so the research organization here was also working closely with CMTI in this initiative. I think the importance of collaboration is becoming just more and more strong as we go. I think there's no way other than this anymore.
Great. So maybe switching gears a little bit, let me sort of ask you, when you look at the research or the scientific advances coming out of India in Siemens, what are some of these things that you would call out as highlights?
I mean, at the core, we are a research organization. While you might know Siemens more for its dishwashers and so on, here in India, at least, we have a large unit that is focused purely on research and pre-development, where I come from. So it's very nice to talk about research and the technology pull all the time. Of course, not for the sake of technology, but for the sake of solving problems. In today's event already, the word ChatGPT was uttered I don't know how many times. So of course, all of you are familiar with it. But what is ChatGPT, right? It is an LLM, a large language model. And if you abstract this a little bit more, it is a foundation model. Now, that's another jargon, so let me simplify. A foundation model is nothing but a model which you train not to solve a specific task, but expose it to a wide variety of data so that it can adapt, it can tackle multiple challenges, right? So similar to how we humans learn, right? So as children, as we grow up, we're not taught to do one specific thing only, right? We're exposed to a variety of experiences so that we grow, we adapt, and then we are capable of tackling any situation, even though we might not have experienced it before. So that's basically the idea of a foundation model, right? And you all are, in one way or the other, exposed already to things like ChatGPT and to Perplexity and Gemini and so on. All of these you converse with in natural language, in English, in Hindi, in Kannada, in whatever other language. At Siemens, we're building an industrial foundation model. Now, what this would allow you to do is to basically converse in the language of technicians, right? In the language of engineers, of operators. And what this means is that we're talking now the vocabulary of, let's say, engineering schematics, of building plans, of 2D and 3D simulations, of time series data from sensors, IoT devices. So you're no longer having to look at complex graphs and charts and simulations and all of this, but you can converse with all of this as a non-technical person even, using common, simple English and any other language. So we're building an industrial foundation model. That's the one hot topic right now, which we're proud of working on. The second one is co-pilots. Now, this is another term that you've heard a lot, right? We have you from Microsoft, and we have the Office 365 co-pilot. We have the GitHub co-pilot, which makes generating code quite straightforward and simplistic. Somebody spoke about vibe coding. So this is all not new. But again, coming to Siemens, we're building co-pilots for the industry. So what would an engineering co-pilot, what would an operations co-pilot look like, right? So these are meant to simplify and strengthen the human-machine collaboration across the value chain. Now, what is part of the value chain? So we start with design. And these co-pilots are then meant to provide multiple design variants, multiple options. Those that are optimized for sustainability KPIs, those that could be optimized for resource efficiency, some for performance, some for cost effectiveness, and so on. After design comes planning, right? So again, these co-pilots are capable of generating the most optimal plans that take into account resource constraints, infrastructure availabilities, human resources available, money, and so on. Then comes, after planning, engineering, right? So while tools like the GitHub Copilot are very well suited for general purpose programming languages, right? For C, C++, Java, and so on. Industry comes with its own set of domain-specific languages. So we have automation code languages, we have languages for rail infrastructure, so Siemens trains, mobility is a huge business, and we have in the rail infrastructure domain very specific languages which people have been trained on developing and building for years, and knowledge workers who understand how to build, even how to develop code in these are not huge in numbers. This is extremely scarce in terms of a knowledge resource. And we're building co-pilots which can understand these very specific domain languages, right? And being able to generate code in these. So the value chain moves on into operations and service and so on, but basically that's the idea of co-pilots in order to aid application builders, in order to aid these developers, using the foundation models at the core of it. And last example I'd like to maybe touch upon is also the last word in the theme, right? Meaning. So while we're talking a lot about AI, the question also is how much can we trust AI, right? How reliable are the results that come out of these AI systems? Is it garbage in, garbage out? Because largely machine learning was based on the data that it was trained on. And if you don't feed it with good quality, high quality data, then you can expect nothing less. And now we're becoming more and more reliant on these systems. Therefore, it's important that we're able to trust them somehow. So in order to make sense, in order to make meaning, interpret these results, what we're heavily researching on is also the area of neurosymbolic AI, right? So this basically is at the intersection of generative AI, but also the symbolic world of knowledge graphs and semantics. And basically the inspiration comes from how humans make decisions, how humans are wired to perform, right? So our brain is composed of neurons, large number of them, but still connected. And knowledge graphs are nothing but these networks which are also made up of edges and nodes, right? Which are deeply interconnected in order to give us rich context. And by leveraging all of this context and neural networks, we're trying to build explanations around this AI black box, right? How can you generate responses that are reliable and trustworthy, robust enough that you can actually move towards autonomous decision making, towards agents and so on. So that's what's happening in the area of research, at least at Siemens Technology.
Okay, very interesting. Yeah, I mean, foundation model for industrial processes sounds very interesting. Although I wonder what AI hallucination would mean in that case. But, yeah, and I know Chinmay is threatening us.
Yes, I feel like that school teacher after the bell rings, waiting for the other teacher to walk out of the classroom. Ladies and gentlemen, let me remind all of you, today is 25th July 2025, because after listening to that conversation for a while, I thought I was in the future in 2028. I thought I was really cool using ChatGPT, and Swathi is like, ChatGPT. Let's give a huge round of applause to our amazing speakers, Dr. Venkat and Ms. Swathi. I believe we have got time for only one question. Yes. Only one question, sir.
Yeah. Sir, you talk about, madam, human, this thing with the interaction with machine. The concept of human in the loop, okay, is also gaining traction. In the sense that, okay, I'm using the machine, I get some input, but I'm not very sure it's right. Okay, so I will not blindly follow the pattern or something which is telling. Okay, so especially networks. Networks are, WANs, other some very complicated stuff. Okay, so one side is that. Another side which is coming up is called agentic AI, right? So I feel perhaps there should be some kind of balance, and would like to understand from you how you guys are thinking to make a balance of it. Thank you.
I can.
You want to start?
Sure, yeah, I can, I think, absolutely, I think this is a very good question. The way I see it, the AI can help human scale, right? Like a human doctor can see 10 times more patients with the help of AI.
Right.
But the human has to be in the loop to make sure the AI is accurate. And, so essentially these human plus AI workflows make a lot of sense in many domains.
Right.
About agentic stuff, yes, it is definitely something that a lot of people are working on.
Right.
But whether we'll have truly agentic things where there's no human at all and sort of agents just talk to each other, we're not there yet. We'll probably get there. But I think right now, having a human or expert in the loop, in fact, we have a project that's doing exactly that, expert in the loop bots for healthcare, for example, right? So, you design it in such a way that the effort for the human is minimal, but they are providing oversight over AI.
To add to what Venkat said, first of all, it's a very interesting question, both aspects of it. Regarding human in the loop, right, we're not looking anytime soon at a completely autonomous or fully autonomous systems, right? So the human very much is still in the loop, or maybe not even the human, but an expert in the loop, like it was mentioned already. And the idea is not only to have the human in the loop for intervention, but also to use the data, the feedback that the human provides in incrementally improving these systems, right? So the two dimensions that we look at this is the human as a student and the human as a teacher, right? So when we say we look at the feedback from the human and use that to improve systems, here the human is acting as a teacher and is giving inputs to the AI. Right. The other dimension, as we are moving more and more towards generative AI and towards agentic AI, is also the human as a student, right? Because somebody said very wisely today that we're no longer the smartest people on the planet, right? The smartest species on the planet. Machines are superseding very quickly. And there are things which machines are simply capable of doing well, doing better than humans. And in these cases, it becomes important to also understand how to interact with these systems, and the human there acts as a student, right? That's the one part. And the second part, you asked about agentic AI, right? Giving an analogy from the space of autonomous vehicles, right? So we have these autonomy levels defined, 0, 1, 2, 3, up to 5. And 0 is where there is absolutely no autonomy, so it's fully human involved. And 5 is...
not me.
And 5 is fully autonomous, right? Where you have absolutely no human involvement. I think we're today, even with agentic AI, still looking at systems that are somewhere at levels 1 and 2, and we'd like to go into levels 2 and 3, but I think beyond that is still a while away. There was actually 2 weeks ago a report by Capgemini which talks exactly about this and saying a lot of organizations, a lot of enterprises are building agentic AI applications, but the question is largely how autonomous and how reliable these are. So I think we're not there yet.